Welcome back, Chemistry Theory. This is the MS3.5 Aromatic Hydrocarbons. So we looked at the alkanes, alkenes, alkynes. We'll look at another group here that involves, it's an interesting way of applying double bonds, as we'll see. So describe what aromatic hydrocarbons consist of, write the structural formula and the IUPAC name for them, and state some properties and uses. So it uses the aromatic hydrocarbons uses the structure of benzene, which can be seen below. So it's C6H6, and you may be thinking, well, how does that, the carbons need more hydrogens than that? But if you take a look at it, here we have a carbon, so a 6-ring carbon, a hexagon, a hydrogen attached to each carbon, and then there are alternating double bonds. So we could have one here, double, single, double, single, double, single. And if you look at each carbon, 1, 2, 3, 4, sharing 4, 2, 4, 6, 8, and gets an octet. Now that double bond could be double, single, double, single, double, single, or it could be, this double bond could be over here, single, double, etc. So in this picture here, sometimes we just draw a circle in the middle just to illustrate that there are alternating double and single bonds throughout the molecule. So what's not shown in this structure, just simply drawing a circle, are the double bonds that are present in the molecule. There are 3 double bonds that are not present in any particular order. So that's a key thing to note. They're not in a particular spot. They are considered to be delocalized, which means they are shared among all 6 carbons in the ring. This makes benzene really, really stable, so it's not willing to give up or gain or lose electrons. The electrons are shared by the 6 carbon nuclei and are harder to pull away than electrons that are only held by 2 nuclei, such as, for example, a single bond or a double bond. So kind of all the carbons share those double and single bonds throughout. Since the double bonds are shared among all carbons, the shorthand method is represented like this. Now I took the molecule and just kind of tilted so the flat parts were up and down, but of course we could have drawn it like this too. We could have double, single, double, single, double, or of course we could have drawn the circle indicating that those double and single bonds alternate. This is the best way to demonstrate that. Best structure to represent benzene. And this is kind of like the second best way, with showing the alternating double bonds. So I'll put next best, the next best way to show that. Okay, so aromatic compounds, organic compounds that contain this benzene ring as part of their structure are called aromatic. And you may have noticed that the word aroma is in there because aromatic was originally used because many benzene compounds were found in pleasant smelling oils that came from spices, fruits, and other plant parts. Hydrocarbons such as the ones we've been looking at before, alkanes, alkenes, alkynes, are called aliphatic compounds to distinguish them from aromatic compounds. And aliphatic comes from the Greek word for fat, aliphatos, since early chemists obtained aliphatic compounds by heating up animal fats. So they come from fats, whereas aromatic compounds come from pleasant smelling things. Naming aromatic compounds. Substituted benzene compounds are named the same way the cyclic alkanes are, so very similar. For example, ethylbenzene has a 2-carbon ethyl group attached, and 1,4-dimethylbenzene, also known as paraxylene, has methyl groups attached at positions 1 and 4. So if you take a look here, so of course we have a benzene, so benzene is there, and we have the methyl group attached at any particular part, so we don't have to worry about numbering it. Ethylbenzene, again, ethyl attached to a benzene. Once I have 2 things attached though, 1,4-dimethylbenzene. Okay? Just as with substitute cycloalkanes, substituted benzene rings are numbered in a way that gives again, we try to get the lowest number to get. So in the following structure, the rings are shown in numbers 1, 2, and 4. So if I look here, if I number it this way, 1, 2, 3, 4, I get 1s, 2s, and 4s. If I had started numbering it here, I'd get 1, 2, 3, 4. So do I pick that one or this one? So 1, 2, 4 is the better structure than 1, 3, 4 because, again, we have the lowest numbers. So when numbering something, if you have a choice to number, make sure you're using the lowest numbers possible, and then chances are that will be the correct structure. So we have methyls at 1 and 4, ethyls at 2, and of course alphabetical, 2-ethyl, 1,4-dimethyl benzene. You can also look at some properties and uses of aromatic hydrocarbons. Here are a few of the many aromatic organic compounds that have practical uses. The common names are used more frequently than their formal names. So here we have naphthalene, which is basically 2 benzenes attached together. And naphthalene is used in chemical manufacturing and in some moth repellents. P-xylene, or 1,4-dimethyl benzene, as you can see it how we would name it, used as the starting material for the manufacture of polyester fabrics. So it's used as the starting material for the manufacture of polyester fabrics. And lastly, anthracene, which has 3 benzenes attached to each other, important in the manufacture of richly colored dyes and pigments. And the last piece here to mention, carcinogens. Many aromatic compounds, particularly benzene, toluene, and xylene, were once used as industrial solvents to dissolve things. Tests have shown, however, that many health risks, including respiratory ailments, liver problems, and damage to the nervous system, were linked to aromatic compounds. So aromatic compounds have been found to be carcinogens. All right, so that's all we have. Now the assignment's kind of an interesting one. It's kind of a fill-in-the-blank type, so fill in the blank with the top. And then the rest of it is multiple choice here, so try to choose the best result that you think applies. Then you can check the answer key. All right, we'll see you again.